Last time, we talked about bodies immersed in fluids. But how about objects that can float in a fluid? Sometimes you might be wondering why ships be able to float while small objects cannot. In this section, we will be applying Archimedes' principles, also known as the principle of buoyancy, in order to solve problems involving floating bodies as well as its stability. As we always observe, whenever a body is placed over a liquid, it either sinks down or floats on the liquid. And when a body is placed on a liquid, there are two forces involved, namely the gravitational force or simply the weight of the object and the upthrust of the liquid or commonly called as the buoyant force. And each direction is upward, resisting the weight of the object. Then obviously, if the weight of the object is greater than the buoyant force, the body will sink. And if the upthrust or buoyant force is greater than the weight, the body will float. The principle of buoyancy is based from Archimedes' principle, which states that whenever a body is immersed wholly or partially in a fluid, it is buoyed up or lifted up by a force equal to the weight of the fluid displaced by the body. To give you a concrete proof of this principle, consider this setup. The weight of the object weighs 7 pounds in still air, but when it is immersed in water, a quantity of water is displaced, and the weight of the displaced water, which is 3 pounds of water, is equivalent to the magnitude of the buoyant force, also 3 pounds. Here are some of the important concepts on buoyancy. So, a body in a fluid, whether floating or submerged, it is buoyed up by a force equal to the weight of the fluid displaced. And the tendency of a fluid to uplift a submerged body because of the upthrust of the fluid is known as the force of buoyancy or simply buoyancy. And the buoyant force acts vertically upward to the centroid of the displaced volume and can be defined mathematically by Archimedes' principle as follows. So the formula for the buoyant force is equals to the specific weight of the fluid multiplied by displaced volume of a fluid.